have to change. So this is also called local operation, local functions. And then you have also focal functions. Focal means what you are doing is basically you are changing your pixel or the cell value, taking your neighbors. Suppose let us work out in this. If I wanted to, if you are worked in a digital image analysis, you might understand these filters. So here when I wanted to change into a focal mean, so then for particularly suppose if this is the value, so then you can take all 3 by 3 neighbors and then calculate sum for this. Suppose if it is a 3, so then take all the values, 2 plus 3, 3 plus 2, 5, 5 plus 7, 7 plus 11, 11 and 2, 13 plus 3, 16. So that means you replace these 3 value with the 16. So then what you will do this, you don't have 8 neighbors for this. If you go to this value, first value, there also you don't have neighbors of 9 neighbors, 8 neighbors. So then for this type of edges, what we have to do is, we have to take only limited edge value. Suppose if this is the value you want to change, we have to take this 4. Suppose 2 to 4 plus 3 is 7. So then you replace this value with a 7. If it is this second value, so then you take its neighbors, but other side there is no neighbor. So then it becomes value 8. Suppose if we come here, again this 3 by this one, and then if it is this, again like this you do, so then it becomes a 6. So like that, it is also similar for other values. If it is this, then again these 6 values. If it is this, again 6 values. If it is this, this. So for all these pixels, it is all neighbors are taken. So like that your output grid is generated. Here in this case it is a sum value. Here in this case it is mean value. Mean is sum divided by the number of cells what you consider. If it is, you see, if it is 7 here, you are considering only 4 cells. So 7 divided by 4, it becomes 1.8. So like that you change your values. So this is called focal functions, taking your neighborhood itself into consideration. So then when you come to the zonal functions, as I mentioned, if you have a district and then if you have your satellite data, then you can convert your satellite data and then make a district map exactly for your district map with the satellite data. So let us do this zonal operation. Suppose if this is the zone grid and this is my value grid. Now here what I am taking is, I am taking a zonal maximum values for each zone. Suppose this is my zone here. So this, for this zone, what is the value, maximum value in that? I can also take minimum value. I can also take sum. I can also take difference. But what I wanted to do, maximum value of this value grid and replace that zonal value. It is here 5. So then whole this zone of 2 is replaced with a 5 value here like this. Suppose if this is a zone 1 and then here if it is a zonal maximum, if there is a 8 value is there. So the 8 value is replaced all these ones and then it becomes 8. So similarly for all other values. So then it comes to the global, it is basically used for calculating the distances. So when we talked about raster also you can divide it into square uniform cells, or you can also divide into rectangle, you can also divide into hexagonal, you can divide into triangle also. So that means your raster can be represented in any one of these forms. But for our convenience and easy operations in a GIS and raster analysis or in a satellite data, what we do is we basically consider a square cells. So that means suppose I move from the center of these cells to center of this cell. So that means I moved one pixel size of distance. Suppose I go this side, it is also 1. So then what will happen? Suppose I move diagonally from here to here. So it is not one cell, it is more than one cell. So diagonal cell. So for that what you are doing is Pythagoras rule if you apply, the square root of x square plus y square, you will get the diagonal value. So here also your cell size is this and then you take a diagonal. So then it is root 2 of that diagonal size. So then it is root 2 of one cell size. You will come a 1.414 into multiplied by cell size. If it is only 1 meter, so then it becomes 1.41 times. So if you go this side, you will go only this center to this center, then you will go only one cell value. If you go from like this, if you go from like this, but go diagonally, it is 1.4. So like that it operates. So basically, when you wanted to operate function, take the global functions. So what we do is we take that values, whatever is given as source grid, convert into 0 values. So those 0 values, and then you calculate the distance. Here 1, 1, 1 is there. Convert this into zeros, 0, 0, 0, and then here also you change it to this, and then you calculate values from all the directions. Suppose I go from here to here, it becomes value 1. If I go from here 1, and then 1 here, and then 1. So like this. So then you can also say that from here to here I should have given 1.4. But it is taking minimum value. You can come from here to here. So that is the minimum. Then if you can go from 1.4 from here. So like that your values are changed. Suppose I go diagonally from this place to this place here. So that means from here to here 1.4 it is. But if I go from here to here 1. And then it is coming from to here. From this to this again 1.4. So like that you calculate values. If you see this here, either I can come from here and then go this place. So that means I have the value here from here to here 1.4 plus again 1, it will become 2.4. But the value here we kept is 2.0. So that means there is from other source the distance is lesser than if you come from this. So that's why if you come from here to here, 1 to again 1 cell, it becomes 2.0. So instead of 2.4 coming from here to here, I am coming straight away from here 2.0. So that means that is the least distance than this. So like that your distance is calculated. All your buffer analysis, buffer zone creation are done using calculating the distance. So those are the different operations, map algebra operations. That is a local function, zonal function, and then you have focal and then global functions. Another important thing when you work in a GIS analysis, I can use two layers combined together. So that is called a crossing operations. So if I merge together, there is something like a geology merged with S. S means shale value. So another way, if you do, all these things are multiplied or crossed together. Forestry is crossed with a alluvial, and the land use here, and then you have geology. And what are those number of pixels? They are crossed together. Here see.